Hello, 8Es, receiving teachers and students. Thank you. May sit down. All right, 8Es and receiving students. Now, in our previous lesson, we looked at weight and volume, okay? And I gave you activities to complete, receiving students. I hope you completed those exercises. If you're receiving teacher, if your teacher can correct that exercise with you later on. Now I have one question, or I'm going to put up the working out for question number 1, all right? Question number 1, where it reads, find the volume of this cube in cubic centimeters and in cubic meters. Now, I'd like you to just check through your answer, okay? Cross-check your answer with my answer that I have here, okay? Now, if you're not sure of any of this working out here, please, I'd like you to ask, okay? Same with you receiving students. Now, again, the question reads, find the volume of the cube. Now, I made a mistake. I said cuboid, right? But it's not a cuboid. It's a cube because, why is it a cube? Because the measurements are equal, 100 by 100 by 100. So the volume of the cube, now who got 1 million cubic centimeters? Receiving students? Yes? Okay, good. Put your hands down. Who got a different answer? Who got another answer apart from 1 million? You want to find the volume of the cube. So using the formula, which is length times the width times the height, right? So 100 centimeters by 100 by another 100. So when we multiply that in cubic centimeters, we have 1 million cubic centimeters. Okay, the next B, you want to find the volume of the cube in cubic meters. Look at the answer. This is the answer. Does anyone know how I got 1 cubic meter? Receiving students? 8Es, did you get that answer? Yes? Okay, how did I get 1 cubic meter? Receiving students? If you're not sure, now you can ask. Okay, it's a good time to ask, all right? Receiving students, you can ask your teacher. Okay, you can ask me, how did I get 1 cubic, 1 cubic meter. If some of you are not sure, receiving students, or maybe would like to help me explain to the students, to the class. All right, Alfred. Yes? All right, I'd like everyone to listen to Alfred, please.
By converting 100 to 1 because 100 equals to 1 meter.
Okay, Alfred. All right, Alfred said 100 is equal to 1 meter. Now 100 what? 100 centimeters. So you see, in other words, 100 centimeter is equal to 1 meter. So to find the volume of the cube in cubic meters, 1 meter by 1 meter by 1 meter, which will give us 1 cubic meter. All right? So that's how we got 1 cubic meter. Okay. You understand? Because if you are not sure, I'd like you to ask. All right? Receiving students, you can also ask your teachers to help you more on that. Now let's look at the second part of that question. All right. It says, if water is filled into that cube, what will be the weight in kilograms? Now you remember the definition of the different units of weight. Yes. Where I told you to copy down receiving students. Now the definition of the units of weight can help you answer this question. Okay? Not back. All right. Question 2, receiving students. Okay, you want to find the weight, okay, of the weight of water in the cube. How many kilograms would that be? All right, I want you to just check with my working out there. Check with your answers and also your working out. And please, you can ask, why? How did I get 1,000 kilograms? Hands up if you got 1,000 kilograms. Okay, good. Only 2 students got 1,000. What about you others?
Can you explain how you got 1,000 kilograms?
All right. Okay, Stephanie, you asked why or how I got 1,000 kilograms. Now, you remember the definition of the units of weight. So, for example, 1 gram. Okay, 1 gram is the weight of. 1 gram is the weight of. Receiving students? 1 gram is the weight of 1 cubic meter of what? Water. Okay? 1 cubic meter of water. Okay? Now, look up here. All right. Because I want to find the weight of this cube in kilograms. So I'm going to use this ratio formula, remember, where you get the multiple of the exterior and multiple of the interior. So 1,000 grams is equal to 1 kilogram, all right? Now, because the volume of this cube is 1 million cubic centimeters. So if I convert that into grams, it will be 1 million grams. Because 1 gram is the weight of 1 cubic meter of water. So that's how I got 1 million grams, which is unknown. We don't know what is the weight in kilograms of this cube. So what I do is I get the multiple of the exterior and multiple of the interior. So 1,000 times x is 1,000. X equals 1,000 times 1 million. Oh, sorry. 1 kilogram times this 1 million. 1 million. And then we divide. X is equal to 1,000 kilograms. All right? So that's how I got 1,000 kilograms. So that's why the definition of the units of weight is very important. Okay, you must not forget that. 1 gram is the weight of 1 cubic meter of water. Okay, 1 ton is the weight of 1 cubic meter of water. Right? All right. So we'll stop there. And now our topic for today. All right, receiving students and 8Es. All right, density. Now, have you looked at density before? Yes? Okay, 8Es and receiving students. think in your science lesson. Yes. Okay. Now, who can tell us what is density, class? Does anyone know what density is? Right, receiving students, you can tell your teacher. Simon? Okay, Simon.
Mass divided by volume.
Mass divided by volume. Okay, thank you, Simon. Yes? Or we can say density is equal to weight over volume. Weight divided by volume. All right. What do we have up here? 80s receiving students? A rock, okay? A rock. Now we want to find the density of this rock. Yes? 80s and receiving students? Now in order for us to find the density of this rock, I'd like you to watch carefully as I show this video. Now make sure you watch carefully so you can calculate or you can find out the density of this rock. Okay, so the weight of the rock, 990 grams. Okay, now we want to find the volume, all right, the volume of the rock. So in order for us to find the volume of the rock, we have a beaker with water, put the stone or the rock into the beaker. Now the water that is spilled, okay, water that is spilled out. Okay, let's just. Okay. Carefully onto. Okay, the water that was spilled out is poured into a, what do we call this? This one here. A measuring cylinder. Okay, good. So the volume of the rock is 320 cubic centimeters. All right, what we used was a beaker, measuring cylinder, spring balance to find the weight of the rock. Okay, what was the weight of the rock? Okay. All right. Sorry. Where am I? Okay. So weight, sorry. All right, the weight was 990 grams. Okay, weight 990 grams. What was the volume? 320 cubic centimeters. Now, I'd like you to work out the density, please, 80s and receiving students. Work out the density of the rock. Now, let's see who will get the answer quickly. Which group will get the answer quickly? Who's got the answer? Who's got an answer, sorry? Okay, if you've got your answer, you can come and write it up on the board. Okay, you can round off your answer. All right, have you got an answer? Yes, okay, good. Right, who would like to give us the answer? Okay. All right, I want you to check with my answer here. Okay, 80s. All right. Look up here, everyone. Did any group get this answer here? Yes? Okay, good. So, 990 grams divided by 320 cubic centimeters, the volume, the density, which is 3.1 grams per cubic centimeter. Yes? 80s? Receiving students? Good. All right. 3.1 grams per cubic centimeter. All right. All right, now listen to this question. Okay, all right, if I have a rock that is 10 times as big as this rock here, okay, we know the density, we know the weight and the volume, all right, of this rock. Okay, let's say if a rock is 10 times as big as this rock, what will be the density? 80s, receiving students? 10 times as big as this rock. What will be the density? Receiving students? Okay. Again, if this rock is 10 times as big, what will be the density? What do you think? Do you think that density will be different this time? Yes. You think it will be different, huh? All right. Okay, with 900, so what are we going to do with the weight? If it's 990 and it says 10 times as big, 990 times 10, which is 9,990, and the weight will be 3,200. Am I right? What's this? Grams, and this is cubic centimeter. So when you divide that, what will be your answer? Okay. Why are you multiplying it by 10 again? Okay, yes. Okay. All right, let's have Christina. Not Christina, sorry. Cynthia. Okay, Cynthia.
3.1.
3.1 what?
Gram per cubic centimeter.
Okay, thank you, Cynthia. All right. Cynthia said 3.1 grams per cubic centimeter. What about you others? You agree or you disagree? Okay, let's see if we have this answer as Cynthia's. Okay, so we divide this 9,900 by 3,200. So cross off the zeros. Okay, 99 divided by 32 is? Per cubic centimeter. So some of you multiplied this again by 10, all right? We only wanted to find the weight, okay? 10 times as big. So 990 times 10, 320 times 10. And then when we get our answer, it's 3.1. So the density is it different or the same? Density is still the same, okay? All right. So now you are thinking now, ATs and receiving students. Okay, just one simple and short exercise before we finish, okay? Class, receiving students, okay, just copy that one down and get the density of this rock. Right? Please, if you have any questions, if you're not sure, please ask, okay? Raise your hands and ask. Also, receiving students, if you're still not sure with how to get the density, please ask your teacher. Okay.
Because I rounded it off. Yes. Rounded it off to the nearest whole number. Okay, what did you get? Did you? Okay, let's see. Alright, 32 to 99. Okay, it's 1. Oh, sorry, 3 goes 3 times. 32 times 3 is 96. Okay. Now, 9 take away 6 is 3. Can 3 go into, can 32 go into 3? So decimal point. And because it cannot go, we have to put 0 here. Understand? So this is also a 0. Because 32 to 30 cannot. So you put a 0 there. And then you add another 0. You see? Am I right? Wait, yes. So 32 into 300, 32 times 9, this is how I got it. 2 9s are 18, 3 9s are 27, plus 1 is 28. So 32 times 9 is 288. You see? 10 take away this 2, 9 take away this 1. Okay. Bring down a 0. 32 into 100 and, I don't know, 32 times 6, so 6 to 18, no, 32 times 4, 2 4 8, 3 4 12, no, 32 times 3, 6 to 3 is 9. Okay, and then go on. So you see, we rounded it off. This 9 is small, so 1 is 3.1.
That's how we got our answer. Okay. Have you got an answer? Yes? Who's got an answer? 8 is? (735) over 250. So the density will be, now you need to divide, calculate, make sure you get your answer, round it off. Okay. My God.
Are you sure it's 2.4? It's 2.4. It's 2.4. Wait. Come on. Is it 2? 5, 3 point. So bring down 0. Oh, sorry. So what's this? A 0. So 250 times 7. 07057 is 35. 2 7 is 12. 14, 15, 16, 17. What did I get? 250. Wait. 250. 02052 is 10. 2 2s are 4. Plus 1 is 5. Who put 600? 5. Am I correct? Yes. So 2. So this is 5, this is 3, and this is 2. So 250 times, let's say 8. 080 5 8 40 2 8 16 plus 4 20. Okay, let's try 9. I don't think so. 0 45 2 9s 18 plus 4. Am I correct? 18 plus 4 is 22, which is 9. 2250. 0 0 is 1, and then it goes on 0 50 times 5 or 4 0. Yeah, correct, which is 2.9. That's how you. So bring down 0. Oh, sorry. So what's this? A 0. So 250 times 7. 07057 is 35. 2 7 is 12. 14. 15, 16, 17. What did I get? 250
Okay, who's got an answer, please? All right, 8Es, receiving students, check with my answer here, and then that will go through the answer. All right, who got 2.9 grams per cubic centimeter? Very good, hands down. Okay. So the answer is, the density is 2.9 grams per cubic centimeter. So you need to practice your division skills. Dividing, long division, that's where you get the, if you know how to divide the longest way, you'll get the correct answer. All right, we'll stop here. 8Es and receiving students. Again, density is weight over volume. Okay. Right, that brings us to the end of our lesson. 8Es and receiving students. Class, can you read out our keyword for today? Density. Okay, thank you for participating in today's lesson.